Hi viewers, so welcome back to the channel. So in this video we are going to discuss the remaining problems of mensuration exercise 2, so which are related to the surface area of combination of solids, right? So already till problem number 4 we have discussed in our previous video. So in this video we are going to discuss the remaining problems. Okay, if you are new to this channel, so please subscribe the channel and watch the video till the end, right? And one more thing, so if you like the video, so please press the like button and share with your friends, right? Let us start our topic. So question number 5. So what is given? A storage tank consists of a circular cylinder with the hemisphere stuck on either end, right? So already you know how a storage tank looks. So it will have a cylinder and it has hemispheres on both the sides. And what are the things that he has given? So external diameter of the cylinder is given as 1.4 meters and length is given as 8 meters. And he did not discuss about hemisphere because so this particular diameter of a cylinder acts as the diameter of hemisphere also, right? Next, what did he ask you to find? So find the cost of painting it on the outside at a rate of 20 per meter square. Now if you want to paint it, so where will you paint? So painting is done on the surface, right? So we need to find out the surface area of the solid, and after finding the surface area we are going to find out the cost of painting, right? Now let us see. So what are the things that are given? So we are given with a cylinder and a hemisphere. Okay, so first of all we are going to talk about diameter of cylinder. So diameter of cylinder d suffix cy is how much? So 1.4 meters. So this 1.4 meters I can write it as 14 by 10 meters, right? So from this clearly I can write out radius of cylinder. No, so radius of cylinder is nothing but diameter of cylinder divided by 2. So 14 by 10, what I am going to get? I am going to get 7 by 10 meters. So this radius of cylinder is nothing but radius of hemisphere also. Radius of hemisphere, right? So radius of cylinder is equal to radius of hemisphere. Next, after this, so what he has given? Height of cylinder is given, no? So height of cylinder is given as 8 meters. Okay, so these are the things that are given. Now to paint, first of all we need to find out the surface area of solid, right? So surface area of that particular tank I need to find out. So surface area of tank is given by CSA of cylinder plus, so here since we have two hemispheres, so both the hemispheres will be congruent, right? So 2 into, so what I can say, 2 times of CSA of hemisphere, right? So from this, so what are the formulas that I am going to get? So it is nothing but 2 pi RH plus 2 into 2 pi R square. So here since we are talking about cylinder, so it is H suffix cy and R suffix cy, here R suffix H, right? So from this, since we did not give any value for pi value, so I am going to consider it as 22 by 7. So 2 into 22 by 7 into, what is radius here? So radius is 7 by 10 into height is given as 8, so 8 by 1. So for our convenience, so if there is nothing in the denominator, so to avoid confusion, so what I am doing is I am going to write by 1 in the denominator. The same way here also 2 2s are 4 by 1 into, so 22 by 7 into, what is the radius here? So radius is 7 by 10 into 7 by 10. So while substituting the values, so please see that so there are no mistakes while substituting, right? So 7 7 gets cancelled, here 7 7 gets cancelled. Now finally what I am going to get? So 22 2s are 44, 44 8s are. So multiply 44 8s. So 8 4s are 32, so 35. So it is nothing but 352 divided by 10 here plus, here what I am going to get? So 22 4s are 88, 88 7s. So I need to find out 88 7s are. So 8 7s are 56, so 5 is left. 8 7s are 56, so 56 plus 6 is 61. So what I am going to get here? 616 by 100. So I am going to get 616 by 100 because here I am having 2 tens, right? Now what I am going to get here? So 35.2 plus here 6.16. Since I am having 100, so I will be getting 2 decimal places, right? So when I add these two, what I am going to get? So here this is nothing but I can take it as 0.20. So this becomes 0.36. So 35 plus 6 is 41. So this is nothing but my surface area. Now what I need to find? So I need to find out cost of painting, right? So to find out cost of painting, what I should do? So to find out cost of painting, so cost of painting is given by the surface area. So whatever the surface area, 41.36 into 20, right? So if you observe this, so because of this 0, 1 decimal place will move, right? So from there, what I am going to get? 41.413.6 into 2. So 6 2s are 12. So 1 is carried, 3 2s are 6, plus 1 7. So 2 1s are 2, 2 4s are 8. So from this, what I can say? Since we are having one decimal point, so what is the answer? So 827.20 rupees. So this is nothing but the cost for painting that particular tank. Okay, so this is nothing but my answer. Next, moving on to one more question. So here, so similar type of question we have done in exercise 1, right? A sphere, a cylinder and a cone have the same radius. So he said they all are having same radius and find the ratio of their curved surface areas, right? So for that, what I am going to do is, so I am going to consider a sphere, a cylinder. So I am going to consider a sphere, a cylinder and a cone. Since all these three are having same radius, so this, if I consider this radius as r, then this radius is also r and this radius is also r. And if you observe this particular height, so this is nothing but 2r only, no, from the sphere. So if this is 2r, that means here for this also the height is 2r, for this also the height is 2r. So from this, what he gave the information is, indirectly he is saying that the height of cone and cylinder are 2r, right? Now what I am going to do is, so I am going to consider the values. So radius of sphere is equal to radius of cylinder is equal to radius of cone is equal to some r, and after that, so clearly I am going to get height of cylinder is equal to height of cone is equal to how much? 2 times of r. Now directly what I need to find? The ratio of their curved surface areas, no? So ratio of curved surface areas means, so CSA of, what is the first figure? So CSA of sphere is to, second figure is CSA of cylinder is to, what is the next figure? CSA of cone. So which gives me, what are the formulas of these? So CSA of sphere, so it is nothing but 4 pi r square is to, CSA of cylinder is 2 pi RH is to, what is CSA of cone? So pi r into square root of, since we don't know what is L, so directly we can write it as root over h square plus r square. Now in all the terms I am having pi as common, so I am going to cancel that, and r also I can cancel, right? So 1 r I can cancel out because all r's are same. Now so 4 into 1 r is to, so here 2 into h I can write it as 2r is to, here r in, so r got cancelled, no? So here what I am going to get? Square root of, so h is nothing but 2r, right? So 2r whole square is nothing but 4r square plus r square. So when I write it in order, so what I am going to get? So 4r is 2, so 2 into 2 again, here again I am going to get 4r. So 4r square plus r square is 5r square. So under root, so this becomes root 5 into, so when I take r square outside the square root, then it becomes r. So among all, again I can cancel out r. So from this, what I can say? So the answer is 4 is to root 5. So here order is important. So when a question is given, so first you need to take sphere, after that cylinder, after that cone. right? So if you interchange the places, then the final answer will be wrong. Okay, next moving on to one more question. So a hemisphere is cut out from one face of a cubical wooden block such that the diameter of the hemisphere is equal to length of the cube. So this particular question is a little different. So you will be understanding that the surface areas does not depend on curved surface areas only. Okay, so already we have discussed previously that so whenever you are combining the figures, so then their bases are getting closed. So because of that we are considering the CSS, right? Here this is not such a case. So here you can easily understand so what the situation is. So what he has given? So he has given one cube. So there is a cube given, right? So here a cube is given. So in this cube what is happening? A hemisphere is cut out from one face. So only from one face a cube. So a hemisphere is being cut out from a cubical wooden block such that the diameter of the hemisphere is equal to length of the cube. Okay, now he is asking me to find out the surface area of remaining solid. So what is happening here? So from this top surface, so if you observe this top surface, so from this top surface what I am going to do is I am removing a hemisphere. So from this top surface I am removing one hemisphere, right? So when I remove this hemisphere, so what happens is, see, this is nothing but my side view. So if I see from side, it looks like this. So when I see from top, so when I see it from top, so from top I can see a square shape. So in that I am going to remove one circle part, right? So from the top if you observe, so from a square face I am removing a circular face. Okay, now if this length is some A units, then what is the radius of this particular part? It is nothing but A by 2. So clearly the radius of this particular hemisphere is A by 2. Now what is happening? Now let us see. So when you scoop out a hemisphere from this face, so from this surface, if you scoop out a hemisphere, so what happens is, so this particular circular surface will be removed, right? So whenever the circular surface is removed, automatically this particular trough part is there, no? So this particular shape will be formed, right? So whenever you remove one surface, automatically, since this is a solid, when you remove a surface, then its place will be replaced with a new surface. Okay, so what is happening here? When you are removing a circular surface, then in that circular surface we are going to get a hemispherical surface. Understood? So this is the main thing that we need to understand. So when you remove one surface, automatically that surface will be replaced by another surface. So in this case a circular surface is being removed, and so this is nothing but that particular part. So since this whole part is being removed, so this circular part will be gone. So in the place of circular part we are going to get hemispherical part. Okay, now let us get into the problem. So you will understand the things clearly after seeing this problem. Okay, now what I am going to do is I am going to consider the length of cube. So length of cube, so I am going to consider it as some A. So if length of cube is A, then what he has given? Diameter of hemisphere is also A only, no? So diameter of hemisphere is also equal to the length of cube, so it is A. Automatically what I can say? So radius of hemisphere is equal to A by 2. Radius of hemisphere is equal to A by 2, right? Now we need to find out surface area of remaining solid. So surface area of remaining solid. So here you will be understanding the complete process, right? So surface area of remaining solid is given by, if you observe this cube, so in this cube how many faces will be? So there will be 6 faces, right? And each side length is given as A. Now in this particular cube, so totally 6 faces are there. So out of these 6 faces, 5 faces are not disturbed, no? So those 5 faces are as it is. Since those 5 faces are as it is, so we can directly take those 5 surface areas, no? So what are those 5 surface areas? Equal to 5 times of a square, because each face is a square, so each face will have the area a square. So such type of 5 faces will be. And next, what is happening here from the 6th face? So from this 6th face, what I am doing? So 6th face area is a square. So from this a square, what I am going to do? I am going to remove this circle area, right? Removing this circle area. So because this surface is being removed, right? So since this particular circle area is being removed, so we are removing pi r square. So when this particular circle is removed, automatically what I am going to get? I am going to get a curved surface area. I am going to get a hemispherical surface. Instead of circular surface, I am going to get. So since we are getting that surface, no, so we can see that surface. So that's why we are going to add the surface CSA of hemisphere. Okay, so what happened? I have subtracted. So when I removed that particular hemisphere, so because of that removal of hemisphere, I am going to remove the surface area of circle. So when I remove the surface area of circle, automatically I am going to get surface area of hemisphere in that place. Now from this, what I am going to get? So 5a square plus a square is 6a square, plus 2 pi r square minus pi r square is nothing but how much? Pi r square. So 6a square plus pi r square is nothing but my answer. But actually what is r here? R is a by 2. So since I need everything in terms of a's, so I am going to replace r with a by 2. So this becomes a by 2 whole square. So from this, what I am going to get? 6a square plus pi a square by 4. Pi a square by 4. So among this, if I take a square as common, so what I am going to get? 6 plus pi by 4. 6 plus pi by 4. Since this is surface area, so we can take it as square units. So we can take it as square units. So what is the answer? A square into 6 plus pi by 4. So I hope you have understood this problem, right? Next, moving on to question number 8. So this is nothing but same model as the previous one. Okay, so there in a cube we have removed one hemispherical surface. Here we are going to have 2 hemispherical surfaces. So 2 hemispheres we need to remove from a cone. Right, so first of all, writing down, so what are the things? A wooden article was made by scooping out hemispheres from each end of a solid cylinder. If the height of the cylinder is 10 centimeters and its base is 3.5, so what are the things that are given? So height of cylinder is given as 10 centimeters, and next its base is of 3.5 centimeters. So here base is nothing but base radius, right? So radius of cylinder is given as 3.5 centimeters. So this 3.5 centimeters I can write it as 7 by 2 centimeters. So this is nothing but radius of cylinder as well as radius of hemisphere also, right? Now from this, if I want to find out the surface area of this article, so since I need to find out TSA of article, so you might have got idea, right? So what are the things that I need to get here? So what are the things that I need to get? So directly what I can do? So I can directly take the total surface area of, so I can take TSA of cylinder. So from the TSA of cylinder, I can remove 2 circle areas, no? So one at the top and one at the bottom. So when I remove those 2 circles, then automatically I am going to have 2 hemispheres, right? So this is nothing but my formula. So likewise you can take, or simply what we can do, so this is nothing but a cylinder, right? So since this is a cylinder, we can take CSA of cylinder. So we can take CSA of cylinder plus, so from CSA of, to this CSA of cylinder, so what we can do, we can directly add 2 times of hemispherical surfaces. Okay, so both the formulas are nothing but one and the same. Okay, if you consider TSA of cylinder, you need to subtract the circle areas, and after that we need to add the hemispherical areas. Otherwise what we can do, so without taking TSA of cylinder directly, if I want to take CSA of cylinder, so this outer surface is nothing but CSA of cylinder. So to the CSA of cylinder directly we can add these hemispherical surfaces. So those two hemispherical surfaces are nothing but given by 2 times of 2 pi r square. Now what is CSA of cylinder? So CSA of cylinder is 2 pi r h. So 2 pi r h plus, so here I am going to get 4 pi r square. So on substituting the values, 2 by 1 into, so pi value is 22 by 7 into what is radius here? So radius is 7 by 2 into height. So height is 10 divided by 1 plus, so this becomes 4 by 1 into 22 by 7 into what is radius? So radius is 7 by 2 into 7 by 2. On simplification, this 7 gets cancelled, 2 gets cancelled. So finally what I am left with here, so I got 220 plus. Now here, so 7 goes, this 2 2s are 4 gets cancelled, and this becomes 154, because 22 7s are 154. You just remember this value, right? So 220 plus 154 is how much? 374 centimeter square. So this is nothing but my surface area of that article. Okay, so here we can use 2 different formulas. So both gives me the same answer. Either you take TSA of cylinder, so from that you need to remove 2 areas of circles, and then we need to add the newly formed 2 hemispherical surfaces. Otherwise what we can simply do, so we can take CSA of cylinder, and for that just add 2 times of surface area of 2 hemispheres. So that also will give you the same answer, right? Next, moving on to one more question. See here, so this is nothing but example 8, so which is given in our textbook. So there is a right angle triangle whose base and height are 15 centimeters and 20 centimeters respectively, and is made to revolve about its hypotenuse. So in a right angle triangle, so there are 2 possible cases. Now if I consider a right angle triangle, and if you rotate about this leg or this leg, so when you rotate about this leg or this leg, then we are going to form a cone. So when you rotate a right angle triangle about any one of its legs, so if I rotate about this leg, so I am going to form one cone like this. So either way you are going to get a single cone, right? Now for suppose if I rotate the particular right angle triangle about its hypotenuse, so the same case I am going to consider. So this is my right angle. So if I rotate the particular cone about its hypotenuse, so then I am going to get a double cone. So double cone means, so I am going to one cone this side and one cone the other side, right? So this is nothing but the situation, so what is given in the question right now. Okay, so now let us find this particular thing. Now what I am going to do, so what I am given with, the base lengths are 30 and 15 and 20 centimeters respectively. Next, this is made to rotate about its hypotenuse. So here we have learnt a particular concept, right? So what is that concept? So when we are rotating a right angle triangle about its any one of the legs, then we are going to form a cone, whereas if you rotate with respect to hypotenuse, then we are going to get a double cone. Okay, now in this particular thing, so what is asking, so find the volume and surface area of this double cone which is formed, and he is asking you to use pi is equal to 3.14. Okay, now let us see the diagram. So when I rotate about this particular BC, so this BC is nothing but my hypotenuse. So about this hypotenuse if I rotate, so this is nothing but A. So at A we are having the right angle. So when I rotate, I am going to form A dash as one more vertex. So based on that we are going to have two cones. So AB A dash and AC A dash. So those are the two cones, right? So from this structure, so what are the things that are given? So this is 15 centimeters and this is 20 centimeters. So automatically hypotenuse will be 25 because it follows Pythagorean triplet, right? Now if you want to find the anything related to, so if you want anything related to a cone or a double cone, so what are the things that you require? So you require height as well as radius, right? Now here what I am going to do is, so here he has taken x, so I am taking this as the radius r, and this I am going to consider it as height. So this I am going to consider it as height of the cone. So if this is h, automatically this length will be 25 minus h. This length will be 25 minus h, because so already we know that the total length is 25. So if I consider this particular part as h, then automatically this is 25 minus h. Okay, now let's get into the problem. So how to solve all these things? So first of all we are going to make use of some particular things, right? So this is my right angle, right? This is my right angle. So if I consider this particular angle as theta, then this angle becomes, so what is this angle? This angle will become 90 minus theta, right? The same way here the base and the radius will be always perpendicular, no? Now from this, if this is theta, this is 90, then automatically this angle will be 90 minus theta. Okay, so from this we are having the angle configuration theta 90 90 minus theta. So if you are having such angles, then we can say those triangles are similar triangles, right? So already in similar triangle concept we have learnt about this. So based on that, so what I can say, by AA similarity, by AA similarity, what I can say, triangle, so follow the order theta 90 90 minus theta. So triangle BAC is similar to triangle, so what is the other triangle which contains the same angles? So BOA. So when two triangles are similar, okay, so when two triangles are similar, then simply what we can say, their sides are in proportion. So when two triangles are similar, simply we can say that their sides are proportional and corresponding angles are equal. So based on that only now we have written this particular statement. So from this what I can say, BA by BO is equal to AC by OA is equal to BC by BA. So I am going to get these ratios. So all these ratios are equal. Now from this, substituting the values, what is BA here? So BA is 15 centimeters by, what is BO? So BO I have considered it as H, is equal to, what is AC? So AC is 20 divided by OA. So OA is considered as R here, is equal to BC is 15, sorry, not BC is 15, not 15, so BC is 25 because it is hypotenuse, divided by what is BA. So BA is 15. Now from this, this goes 5 times and this goes 3 times. So this ratio is equal to 5 by 3. Now on comparing these terms, so we are going to get the value of H and R. So from this what I am going to get, so 15 by H is equal to 5 by 3. So in numerators this 5 goes 1 time, this 5 goes 3 times. So when I do cross multiplication, so height is nothing but 9 centimeters. So the height of this particular cone, so this particular cone is 9 centimeters, right? Next, one more thing, so 20 by R is equal to 5 by 3. So this in 5 table it goes 4 times, goes 1 time. So from this radius I got it as 12 centimeters. So I got radius is equal to 12 centimeters, height is equal to 9 centimeters. Right, now first thing, what did he ask you to find? So volume. So if I want to find the volume of double cone, so volume of double cone, so V suffix DC is equal to volume of cone 1 plus volume of cone 2. So directly I can write as volume of cone 1 plus volume of cone 2. So what is volume of cone 1? So 1/3 pi r square h1 plus 1/3 pi r square h2, because both are having the same radius. Right, now directly, so 1/3 pi r square, 1/3 pi r square I can directly take common. So 1/3 into, so what is the value of pi here? 3.14 he asked to take. So 3.14 into, what is the radius here? So radius is 12, no? So 12 into 12 into, so what I am going to get? h1 plus h2. So from the figure, so if I consider this as h1 and this is h2, so if I add these two, so this is going to give me, so what I am going to get? So h1 plus h2 is nothing but 25 only, no? So this 3 in 12, so in 12 it goes 4 times, so I am going to get 4 here. So what I am going to get? 3.14 into 4 into 12 into h1 plus h2 is nothing but 25. Now 4 25s are 100, so keep that aside. Okay, next multiply this 12 and 3.14. So 12 into 3.14, so 3.14 multiplied by 12. So 12 4s are 48, so 4 will be left, 12 1s are 12, so 12 plus 4 16, 1 is left. So 12 3s are 36, 37. Now what I am going to get? So here two decimal values, no? So 37.68. So 37.68 into this 25 4s are 100 now again. So that, so this 3.14 into 12 is 37.68 into 100. So this gives me, so because of this 100, these two decimal points will vanish. Then from this what I am going to get? The answer is 3768 centimeter cube, because it is nothing but volume. So volume is centimeter cube. Right, now we are going to find out the surface area. So to find out surface area, so this time I need to find out surface area of double cone. So the surface area of double cone is given by surface area of, so it is nothing but CSA only, no, because both the bases are combined together. Right, so CSA of cone 1 plus CSA of cone 2. So CSA of cone 1 plus CSA of cone 2. So what are the formulas? So pi r pi r1 l1. So here both r's are same, so pi r2 l2. So from this, so directly 3.14 into, so pi r1 pi r2 both are same, so 3.14 into radius is how much? 12 I think. So radius is 12 centimeters, right? So radius is 12 into L1 plus L2. So slant height of, so already we have found 3.14 into 12, no? So what is the value? 3.14 into 12, 37.68. So this is 37.68 into, so what about L1 and L2? So this is L1 and this is L2. So what is that? 15 plus 20. So this is 15 plus 20. So which I am going to get? So 37.68 into, so 15 plus 20 is 35. So doing multiplication again. So 37.68 into 35. So 5 8s are 40, 4 is carried, 6 5s are 30, 34, 3 is carried. So 7 5 is 35, 38, 3 is carried, 5 3 is 15 plus 3, 18. Next 3 8s are 24, 2 is carried, 6 3 is 18, 20, 2 is carried, 7 3 is 21, 23, 2 is carried. So 3 3 is 9 plus 2, which is nothing but 11. So 0, 8, 8, 8 plus 3 is 11. So 1. So what is the value? So since we are having after 2 decimal points, so this becomes 1318.8 centimeter square. So this is nothing but my answer of surface area of that particular cone, right? So the answer is 1318.8 centimeter square, right? So thank you for watching the video. So in the next video we are going to discuss about the other topic related to mensuration. Okay, thank you for watching.